Hello everyone, welcome to the first tutorial of network theory. In this tutorial, we will be discussing about classification of element. Okay, before proceeding further in classification of element, I am considering that you know about resistance, inductance and capacitance and Ohm's law. Okay, I am considering that you know the basic concept of resistance, inductance and capacitance and Ohm's law. Okay, now let's proceed to classification of element. Well, element is classified in four categories. First one is the linear and non-linear element. Second is active and passive element. Third one is the unilateral and bilateral element. And fourth is time variant and time invariant element. We will be discussing one by one. Let us proceed to first one, that is linear and non-linear element. An element is said to be linear whose VI characteristics follows only one equation of a straight line. I will highlight this. Only one equation of a straight line passing through origin for all time. You have to check these things while finding whether the element is linear or not. Now let us check whether this graph number 1 is linear or not. How will you find that VI characteristics is linear or not? You have to find just by saying these things. Only one equation passing through origin and for all time. See, this is following only one equation of a straight line. Also it is passing through origin and it is following equation of a straight line for all time. It is never be a constant value. So this is linear. Let's move to second. This is also following the equation of a straight line which is passing through origin and for all time. It is not constant for any value of voltage or current. That means it is also linear. Now see this. This is following only one equation of a straight line. Correct. This is not passing through origin but touching the origin. But it is not following for all time. Okay. See, for V less than 0 you are not getting current. When you reduce the voltage in negative direction you are not getting the current is 0. That means it is non-linear. See this. This is one equation of a straight line. This is one equation of a straight line. Means overall the graph contains two equations of a straight line. But for the graph to be linear it must follow only one equation of a straight line. So this is also non-linear. See this. For increase in current the voltage remains constant. That means after this value it is not following equation of a straight line. So it is not following equation of a straight line for all time. Not for all time. That means it is also non-linear. See this. For I less than 0 you are not getting voltage, or you can say that for V less than 0 you are not getting current. So this is also non-linear. This is also non-linear because for I greater than 0 you are not getting any voltage, means it is not following equation of a straight line for all time. This is not passing through origin, so this is non-linear. This is also not passing through origin, means this is non-linear. See, this is linear up to this point. Okay, after this point the voltage is constant no matter whatever the value of current is. Okay, so overall it is not following equation of a straight line for all time. That means it is non-linear. So you can see that only graph 1 and graph 2 are linear, otherwise all the graph are non-linear. Now see active and passive element. An element is said to be active which delivers net amount of power to the circuit, otherwise it is passive. Means example, voltage source, current source and the battery. Battery is delivering power to the load. Suppose one voltage source I am connecting having V magnitude and one load I am connecting of R. That means the current will flow from positive terminal of V to the load. That means it is delivering power to the load. So this is active element and this is passive element, because it is consuming power or dissipating power, it is delivering power. Okay, so an active element is those element which delivers net amount of power to the circuit. Remember one more point, RLC element are known as passive element only if R greater than 0, L greater than 0 or C greater than 0. How we can determine whether the element is active or passive in graph? Let us see. See this first graph. It's very easy to know whether it is active or passive. If graph having positive slope, means that that element is passive. If graph contains of negative slope, that means that element is active. Now see, this contains positive slope, right? Means this is passive. Of course, we know V is equal to IR. Okay, for R is the nothing but the slope. So if R is greater than 0, means the slope is positive, means that element is passive element. Okay, see in this graph second, this is having a negative slope. Slope is always measured from positive axis, so this is having negative slope, means element is active element. See, this is having positive slope, means passive. This is having positive or negative, this is also having positive slope, not negative. If you will calculate the value of angle of this, slope is nothing but tan theta, so tan theta is measured from, if you will extend this, then you will get positive slope, right? Slope is nothing but this is, so magnitude of voltage is minus V here and magnitude of current is minus I, so minus V upon minus I will give you positive slope. Got it? So this is also passive. Now see this, V is positive here and I is negative, so V upon I will give you a slope, right? So overall slope is negative, means this is active element. So in nutshell we can conclude that if graph will lie in first or third quadrant, then that element is known as passive element. Second, if graph will lie second or fourth quadrant, then that element is known as active element. Now see, unilateral and bilateral element. An element is said to be bilateral which offers same impedance, when the polarity of voltage or current get reversed. I am taking voltage, but you may take here as a current also. Suppose current source is connected, no problem. So an element is said to be bilateral which offers same impedance when the direction or polarity of voltage or current get reversed, otherwise unilateral. In graph, how we can analyze that whether the element is bilateral or unilateral? It's very easy. See, what is saying, which offers same impedance when the polarity of voltage get reversed. Let us suppose at V is equal to V1, the current is I1. Okay, at V is equal to V1, the current is I1. So let us suppose Z1 is equal to, now Z1 is equal to what? V1 upon I1 at this point. Okay, now you reverse the polarity of voltage or current, no problem. I am reversing the polarity of voltage, means I am reversing the polarity of voltage. That means I am taking minus V1 at V is equal to minus V1. I am getting what? Minus of I1. Why? Because this is equation of a straight line. So at V is equal to V1, if you are getting I is equal to I1, that means at V is equal to minus V1 you will get I is equal to minus I1. So if you will find here Z2, that is equal to minus V1 upon minus I1, that is nothing but V1 upon I1, that is equal to Z1. So in this graph you can see that after reversing the voltage we are getting same impedance. After reversing the voltage we are getting same impedance, means Z1 is equal to 0, hence it is bilateral. Okay, now see in second graph. At V is equal to 4 volt I am getting I is equal to 4 ampere, means Z is equal to 4 by 4 V upon I, that is equal to 1 ohm in first quadrant. Now see in third quadrant, at V is equal to minus 4, at V is equal to minus 4 I am getting minus 4 ampere of current, means Z2 is equal to minus 4 upon minus 4, that is equal to 1 ohm. So after reversing the voltage I am getting same value of impedance, means this is also bilateral. Okay, now see this problem. At V is equal to 8 volt I am getting I is equal to 4 ampere, means in first quadrant impedance will be 8 by 4, that is equal to 2 ohm. Now see in third quadrant, at I is equal to minus 4 ampere I am getting V is equal to minus 6 volt. In this case impedance I am getting minus 6 by minus 4, that is equal to 3 by 2 ohm. Here I am getting different impedance when the polarity of current get reversed. Got it? When the polarity of current from minus 4 ampere to minus 4 ampere, then the voltage is not same, means they are offering different impedance. So this is unilateral. Okay, take one more example of unilateral. This is also unilateral. This is V and this is I. You are getting Z is equal to V1 upon I1. This is I1, this is V1. But when you reversing the voltage, that means at V is equal to minus V1 you are getting current is 0. At V is equal to minus V1 you are getting current as 0, means Z is infinite. So this is offering different impedance when the polarity of voltage get reversed. Got it? So this is also unilateral. So here we can conclude one point. Every linear element is bilateral, but converse is not true. Means every linear element is bilateral, but not every bilateral element is linear. Like see in this case, this is linear element because it is following one equation of a straight line passing through origin for all time. So this is linear. Okay, this graph is linear, and this is also bilateral, means every linear element is bilateral element. But see this second case, this second case is we are getting bilateral element, but this is non-linear. Why? Because after V is equal to V, after I greater than 4 ampere we are getting constant voltage. Got it? So this is non-linear, but this is bilateral. Got it? So take this point, this is important point. Now see time variant and time invariant. This is very simple. An element is said to be time variant whose VI characteristics changes with respect to time. whose vi characteristics is changing with respect to time, then that element is known as time variant element, otherwise time invariant. See, I am making the vi characteristics of one element. This is the vi characteristics of one element. Okay, at t is equal to t1, I am getting like this. Okay, the vi characteristics like this, but after some time t is equal to t2, I am getting the vi characteristics like this, means the slope is changing. Initially the slope is tan theta 1, and after some time the slope is tan theta 2, means the characteristics vi characteristics is changing, means this is time variant. Got it? Now let us solve some numerical based on classification of element. I have given some graph in which you have to find the nature of element, whether the element is linear, unilateral, bilateral, nonlinear, active, passive, whatever it is. So see in the first graph, this graph is linear. Why this is linear? Because it is following the equation of a straight line for all time and also passing through origin. So this is linear. Every linear element is bilateral. I have mentioned in earlier point. Okay, so no need to check the bilateral if the element is linear. And the third one is whether it is active or passive. See, this graph is lie on first and third quadrant, that means this is passive, or you can say that the slope is positive, means the value of r is greater than 0. V upon I is nothing but greater and nothing but r, that means the value of r is greater than 0, so this is passive. V upon I must be positive for passive. Check this, this is non-linear. Why this is non-linear? For v less than 0 the current is 0, so not following the equation of a straight line for v less than 0, so overall graph is non-linear. Bilateral or unilateral? This is unilateral. Why this is unilateral? Because in first quadrant you are getting some impedance, but in third quadrant you are not getting. For v less than 0 the current is 0, or for I less than 0 the voltage is 0, so unilateral. Active or passive? Passive. Why? Because slope is positive, v upon I is greater than 0, so passive. Check this, this is non-linear because it is not following equation of a straight line for all time. After I greater than 4 the voltage is constant, so non-linear. Unilateral or bilateral? For bilateral, check, for at v is equal to 4 I am getting I is equal to 4, that means z is equal to 1 ohm. Okay, at v is equal to -4 I am getting I is equal to -5 ampere, this is -5 ampere, so z2 is equal to 4 by 5, which is not equal to 1, that means this is not bilateral, this is unilateral. Active and passive? Of course passive. Why? Because graph lies in first and third quadrant. This is linear. Why? This is following equation of a straight line passing through origin for all time, so linear. And every linear element is bilateral, so no need to check about for the bilateral. Now see whether it is active or passive. Graph lies in second and fourth quadrant, that means active. See this, talk about the linearity. This is non-linear because it is not the equation of a straight line. Also unilateral. Why? Because when you are reversing the v is equal to v1 you are getting I is equal to I1, but when you are reversing the polarity v is equal to minus v1, then also you are getting I is equal to I1 only, not minus I1. So overall in Z1 is positive and in fourth quadrant Z1 is negative, so overall this is unilateral. Now talk about active and passive. I told you earlier that if the graph is lie in first or not and or third means passive. Okay, and if graph lies second or fourth, that means active. What will happen if the graph lies first and fourth or second and third? Then also it will behave like an active element. Passive plus active. In this case this is passive, and in this case this is active, so overall the element is active. Remember this. So that's all about classification of element. In the next tutorial we will see classification of sources. Okay, if you guys are having any problem in this lecture, then you can ask in our Facebook group. Link description is given below. And for new updates please subscribe to this channel. Thanks for watching this video.